The range is a measure of variability, although considered an imprecise one. We will spend the rest of the time discussing the two other measures of variability, variance and standard deviation. Variance and standard deviation are mathematical partners in that if you know one, you can easily calculate the other. There are formulas for each measure, a formula to calculate the variance and a formula to calculate the standard deviation. You will learn how to calculate the variance first, and once you calculate that number and you have it on your calculator, all you have to do is punch the square root button on your calculator and you will have the standard deviation. The standard deviation is the most commonly used and most important measure of variability. Standard deviation uses the mean of the distribution as a reference point and measures variability by considering the distance between each score and the mean. It determines whether the scores are generally near or far from the mean. That is, are the scores clustered together or scattered? In simple terms, the standard deviation approximates the average, or standard, distance a score value is from the mean. In this text, you will learn how to calculate the variance first, and from that, you can easily calculate the standard deviation. The variance is a somewhat abstract index that gives you an idea how spread out or dispersed the scores are in your data set. Very simply, the larger the variance number, the more spread out your scores are. In this book, we will use a three-step process to calculate the variance. In step 1, to calculate the variance, you must first compute or calculate something called sum of squares, or SS. Your book provides you two formulas to use to compute the sum of squares, the definitional formula and the computational formula. The definitional formula is useful to understand the concept of sum of squares, but because it is an easier formula to use, we will use the computational formula with our problem sets. The concepts of standard deviation and variance are the same for both samples and populations. The details of the calculations differ slightly depending on whether you have data from a sample or from a population. You will be learning a three-step process to calculate standard deviation. In step 1, you calculate the sum of squares, or SS. On the slide, the bullets under the definitional formula help us understand the order of operations for SS, which stands for the sum of the squared deviations about the mean. In the definitional formula side, to the right of the equal sign, following down the bullets, each component of the formula is defined and spells out a step of the definitional formula. A deviation score is when you subtract the mean, whether it is a population or a sample mean, from each score value. This is called a deviation score, and you will see this term come up periodically throughout the semester. For any data set, when you sum the deviation scores, without first squaring them, the sum will always be 0. The second step in the order of operations, according to the bullets listed on the slide, is to square each deviation score. Squaring is very useful in statistics because it turns negative numbers into positive numbers that you can work with. Finally, you sum the column of squared deviation scores, and that gives you the SS, or sum of squares. On the right side of the slide, looking at the computational formula, notice that the components look very familiar because you learned them in Chapter 1. While both formulas will give you the exact same number, the computational formula is easier to use, so plan on using it for every requirement to compute SS in the future. Next to the link to this presentation video, look for a link to a worked example of a problem that computes SS, or sum of squares, with both the definitional and computational formulas.